All right.
Great. It's my pleasure to introduce Dr. Daniel Garijo, who is an associate professor at the Artificial Intelligence Department at Universidad Politécnica de Madrid. He's a researcher at the Ontology Engineering Group and a frequent collaborator with the Information Sciences Institute at the University of Southern California. His research activities focus on e-science and the semantic web, specifically on how to increase the understandability of research software and scientific workflows via their provenance, their steps, outputs, inputs, intermediate results, and exposing those as linked data. Daniel will be speaking with us today about autocodemeta, a tool that he and his colleagues have developed to automatically extract code meta from research software code bases at a given GitHub URL. Thanks for presenting today, Daniel. I'll turn it over to you.
Thank you. Thank you very much, Alan. And I'm sorry for all this setup. You'll see me that I'm outside now because I was having a meeting here in Switzerland today, and I just ran out of the meeting to give this brief presentation per Alan's request. So the setting is a little strange, but I hope it works. So let's see. Today, as Alan said, I'm going to be speaking as a brief presentation about the autocode meta generator because I showed a demo a couple of meetings ago. And it was, I mean, some people were asking me, oh, how does it work and so on. So I wanted to, let me first hide this, which is a little annoying from Zoom. There you go. Okay. So a little bit of motivation about the problem is that I think we are all familiar with this, no? But there are many software metadata formats, and for any of us that work, I don't know, with software repositories, you have seen that in Python you can put in you can describe projects with a .cfg, a set of .py. If you work in Java, you have pom.xml. In R, you have the description files. Now we have the citation file format, which is great because it gives you some means to describe authors and its metadata. But you also have the authors file, the contributors file, the license file. You also have GitHub APIs, PyPy, Theorem, Maven, NPM, Debian, Docker files. So all these things have some sort of software metadata, even though some are like Docker files, right? They may describe only software images, but it still is related to software. And there are also many software metadata schemas. I listed some in here, like this the software ontology, the software description ontology, Ontosoft, Wikidata, DOPE, which stands for description of a project, schema.org, etc. And extending schema.org, for those that are not familiar with the schema.org, but I think most of the people in this audience are, is it's a metadata schema that's where search engines use to describe resources on the web. And CodeMeta has emerged as an extension of schema.org that acts as well as a Rosetta Stone for software metadata. So CodeMeta has two parts, no? On the one hand, you have the schema that introduces minimal metadata extensions to schema.org. And the most valuable part, at least from my point of view, is the crosswalk, because it tells you how each of the existing metadata schemas translate into the CodeMeta project. And this has been a collaborative project. It has been driven in the last years as well a lot by Moran from Software Heritage and with collaborations from the community, including the Sidecodes community, right? So basically, we all have contributed to making this happen. And the problem here is like, okay, well, now we have this new standard, CodeMeta, or community standard named CodeMeta. So how do we create these files? These files take the form of a JSON LD format, and Software Heritage put together this very nice website, which is the CodeMeta generator, where it's a form. And in this form, you basically fill in all the metadata, and you also have, and then you will see as a result on the bottom part of the website, um, well, the JSON LD format that also is validated, right? So if you put, I think if you try to put a license that is not correct, it will tell you, hey, this doesn't seem fine, and so on. The only problem, of course, is that you need to fill in this information manually, and that takes time, right? So we, and by we I said in my group, we did a small extension. We actually forked this project um, to create an autocode meta generator, which will go to the GitHub repository. That's why you see the URL over here. The URL of the autocode meta generator is, oh my God, it's the w3d.org/autocodemeta. And this will take you to a website that is very, very similar to the code meta generator, but the only difference is that you input the URL of your repository in GitHub or in GitLab. We don't support Bitbucket at the moment, only GitHub and GitLab. And then you click this button and it will try to fetch all the metadata from the code repository and show it to you, right? So the input is your code repository and the output is the code meta file. The code meta file in the similar way that the code meta generator does it. Basically, it shows all the file and all the fields of the form that were found in the repository are filled. So if you see that, I don't know, there is something wrong or that could be complemented, you can change it by hand and still get the code meta file. There are a few differences that we have expanded from the original code meta generator. One of them being that now for the software requirements, we also include the version. I think that all these release notes, they come from also from the latest release, and that in the reference publication, we expanded the fields to include the authors of the publication and metadata from the reference publication that is available in that repository. We did this because, well, we were very interested in having this information available, and we expanded a little bit the code meta generator with this. In addition, we realized that according to the latest version of schema.org and code meta, keywords can be either concepts in a taxonomy, or they can be keywords like text. So we also updated this to support that, right? And I think, well, that's pretty much it, like the form that and what it supports. The architecture is very simple. So you have a client and a server. And in the server, which has this API that is in the slide, you can send as part of the URL, the URL of the repo that you want to access, and it will return a code meta JSON file that is used by the client to show all the filled in fields, right? There are some limitations right now because we are offering this as a free service, but I think there is a limit due to the way that the GitHub API is set up. With the key that we currently have, I think you can do around 2,000 analysis per hour, which I think it is still a lot. But if you want to do some bulk analysis, you can or you can just clone the repository, put your own GitHub API key, and do the analysis in bulk by yourself, because that's why we have the code repository, right? So you can deploy it with your own key and offer it to your community if you think the service that we provide for free is not enough. This next question is, okay, but how is this metadata being gathered? So we use the SOME framework, the software metadata extraction framework, which given a repository, it will go through the README and through the different files, including Docker files, including metadata files like the pom.xml, setup.py, also the GitHub API or the GitLab API if you go in GitLab, and it will extract the results in codemeta. Of course, by doing this, and also it also extracts the provenance. That is that if you have conflicting information, for example, you have a code meta file with a license, and then you have the license that is different than the one you declare, it will tell you, well, I found two licenses, but it doesn't take any decisions unless you do the export in code meta. But I think in code meta, since you can have multiple licenses, this would be technically correct. So in the end, you get a structured representation of the metadata, and that is the one that the client uses to represent the information. A few of the things that we recognize are listed here. So we use different techniques. Some use slight supervised classification, but also we do header analysis for the README files. We explore different types of files. Of course, we apply a lot of regular expressions which work very well, like how to get the Zenodo DOI from the README file. This works with a regular expression, so we are not going to use anything that is more elaborate to do that, right? And we try to translate all of these into codemeta as much as codemeta supports it, right? We also use the codemeta project and the crosswalks, the documentation from the crosswalks, to incorporate some of these into the different files that are available in our repository. Um, and just to wrap up a little bit, since this is a short presentation, there are some remaining challenges, right? As I said, sometimes you have multiple sources of metadata and it's not clear which of those sources is more authoritative. So for example, what happens if you have a code meta file and a CFF file and package metadata file? Which one should you consider more authoritative to take the decisions based on metadata? Some people may say, yeah, look at the code meta file, but some other people may consider that the things that they have in their package file are more authoritative. And usually this is not a problem because the metadata is or is supposed to be consistent, but in cases where it's not, then you may have to consult the user, right? Also, we have some representation issues that we have taken some certain liberties in the current export for CodeMeta, but there are some limitations into what CodeMeta supports, right? So, for instance, as I was saying before, keywords may be terms or URLs, but there are no agreed vocabularies for defining them, no? So shall we link or decide on recommended vocabularies to link keywords for having a more proper cohesive set of keywords? In licenses, the consensus seems to be SPDX, but now that we have license expressions, for those that don't know, allow, for example, licensing certain part of the documentation on CCBY and the rest of the code on MIT. But the license expression would be something like MIT and CCBY. So what does apply to what and how do we express this in code meta is very confusing to me. I don't think this is possible so far. I may be wrong. Also, some languages have too little constraints, right? So in the crosswalks, we are having some issues like the ones listed here. So an author is can be the name of and the surname of an author, but it can include the name, the address. It can include multiple authors separated by commas. So if you start applying regular expressions, it's not that easy, especially when multiple authors are included in the same field, or people do just list people, and well, it's kind of tricky sometimes, no? And even though we have not discussed this in particular in CodeMeta, was following some of the documentation, and for example, even though you can point to the version, it is not clear now how to point to version intervals in the versions of the requirements in CodeMeta, right? How do you say that it's not version 1.4.3? It's just that this software is compatible with something bigger than, say, version 1.4.3. You can do bigger than whatever, but then that is not, there are some hidden semantics into how you're representing that, right? And I don't think we have come up with best practices in psychodes to make this happen as a community. So that's a little bit what I wanted to tell you today. I can show you a demo if you are interested. I hope that my internet connection is good enough, or you can just test it yourself with your repositories. Of course, the bigger the repository you want to assess, the more time it will get because it downloads the repository to do the analysis, right? But if you have any feedback or issues, please open an issue in either SOME for the autocodemeta repo, and we will have a look. As for the next steps, we are working on improving the support for additional recognition of metadata fields and also including metadata suggestions on things that may be improved in the form, right? Also, the detection of conflicts that I mentioned when you have things in different metadata files. All right, so without further ado, I think let's see if my internet connection allows for a demo. I used one of the packages from Rebecca Ringet from NASA because she was very keen on giving us a lot of feedback about the app, and she was quite happy to see the results. And you can see here a little bit of the results, no? So I put the URL. It took a little bit of time analyzing the repository. It will take the description, taking, I can't remember, probably from the README file uh, or from the description in the GitHub API. It takes that the license is the BSD2, the programming language, extracts all the requirements in Python. There are some that, well, may be improved, but in general, it does quite a good job. It also recognizes the reference publication. It lists here, and it shows that it's a publication with 35 authors. If you move on here, you see all the keywords. And finally, you get the codemeta.json, which is the result, right? So, which in this case is very long because it extracted a lot of things. So that's it. Thank you very much, and I'll be happy to take your questions.
Great. Thank you so much, Daniel. Are there any questions to start with? If there are, just please just raise your hand. I think this is definitely a huge step forward. I think I have the usual set of questions. If no one else has anything, but I think Pete has one quick question.
So
Please go
I
ahead.
have, cut off the answer to as quick as you want because both of these may be blue sky questions. So I guess for the first one, you'd mentioned regular expressions being sometimes problematic. Have you looked into using some of the smaller language models to do like named entity recognition or anything along those lines?
Yeah, I started looking at it, but even the small language models take a huge computational toll. So it is something that adds, because look, even just adding simple supervised classification based on, you know, very, very fast models, which are not even large language models or even language models, it makes the stack of the library turn grow like almost a gigabyte, and that's why in the SOMEF core, which is what Alan and Tom and others asked me to separate, I removed all the machine learning stuff, and suddenly it's a very lightweight package that is easy to install. So it is something that I would like to explore in the future. It is something that is not included at this time. We only include very basic supervised classification, but for the detection of descriptions, and it was the descriptions and field of science classification as well. So it will try to tell you, yeah, this looks like a machine learning project, right, or something like that.
Cool, thank you. Yeah, it's good to have practical. Yes, you thought about it. It's not great here. And I guess second blue sky question, when you were talking about the authors being represented potentially different ways, I am not sure if this is supported by this schema, but I have seen some metadata schema that will support multiple entries for the same type with annotations based on the source or where it came from. The downside of that is that you lose a canonical output, but then you've translated all the information into a machine actionable form upstream.
Oh, no, don't get me wrong. So it is supported in codemeta. Codemeta supports the representation of authors perfectly. However,
for the extraction, yes.
Yeah, what is a little messy is that when I go to so for example, the examples I showed were from PyPy, right? And this is taken from these examples are taken from the specification. So this is probably one of the use cases where a small large language model would be interesting to see what is how does it improve, because let's face it, most of the people just put the name and the email, right?
Yeah.
But then there are the cases where they don't, and then it messes everything up. But here is where maybe adding a small LLM, we would have to do the analysis. And if you'd like to collaborate on this, I would be more than happy to do this in the future. It's an interesting project because all the data in PyPy is open, so we
Yeah,
can check, hey, how much does this happen, and where would we have problems, right?
cool. But it doesn't support like, 3 entries, or does it support 3 entries for the same thing with some
Yeah,
annotation in it?
as far as I know, so in the this is the author field. So one thing that it frustrated me is that there are a lot of redundancies. So for example, there is an author email, but in the author email you can put the author name.
Ah,
Or
good.
you have
Yeah.
maintainer and author, but in author you can list multiple people separated by commas, or following this thing that I say here with email address including commas and then another author, right? So uh, it's a little bit heterogeneous. I think they wanted to be as flexible as possible for people to submit metadata, and then the thing just grew.
Yeah. Well, thank you very much. I don't want to take too much time for blue sky questions. So thank you and great presentation.
Thank you.
Next, we have a question from Christian, and then Hervé.
Daniel, thanks so much. This is really exciting, and I should give you fair warning. You might need a bigger server when we start poking around at this and use it for our own. I have two questions if your battery allows. First is that uh, thinking about what this can do really uh, brings out the fact that the code meta is now really a snapshot in time. You do this against an actively developed repository, and you're going to get a different code meta today than you do tomorrow. Presumably, in theory, for every released version, you'll have a different kind of perhaps canonical version of that code meta. Can you comment on if you thought about that, or what might be the best way to handle that?
Sure, give me 1 second because my laptop is shutting down, and I want to make sure that that at least that there is a co-host. So, okay, so Alan, I'm gonna make him host. Change host very quickly just in case something happens. And I'm gonna disconnect from my laptop and stay in my phone. Apologies for this, but this is what I can do. I'm juggling too many things at the same time. Okay. So the question, which is like, what happens if you have things that evolve over time? It's a question that I gave some thought, and um, things evolve over time, but usually in packages you have a release, right? And the release is snapshotted. So usually what codemeta describes may be associated with a release, which is then deposited in Zenodo and software heritage. And this is the thing that you want propagated. And this is why when you describe the thing, with the software metadata with SOMEF, we take the descriptions from we associate this to the latest version of the software, no? So basically that the thought in which this is supposed to be used is that when it's deposited or when it's released, this will be the metadata file that will be inserted there, right?
Do you record the generation date or the commit or the version tag?
We we record the version number that is we have a small field for the provenance of the extraction that I think it includes. Well, it definitely includes the version of SOMEF that was used because SOMEF is also changing, and it includes the extraction time, I think, but I would have to double check.
Okay. All right. Thanks so much. That's really, really cool.
Thank you.
Great question, Christian. Next is Hervé.
Yeah. Hi, Daniel. Great presentation. One question I was wondering. So, in the challenges, you mentioned that sometimes it's hard to tell which source of information is the more authoritative. I share this bitter experience with you. One thing I was wondering was whether it could whether this is a matter of extracting the metadata, or whether this is more of a matter of repository stewardship. Basically, the most usual case I've seen with this is people updating version number in one of the files and not in another one. This is like I mean, 3 out of 4 cases are this one. And I was wondering, first of all, it raises a question on whether this could be solved by checking between the different sources of information, which one was updated the latest, and it could help weigh out which one is the best, and also it could be seen. I mean, I don't know. I'm just thinking out loud, but could it be that what you've been building could be used also to make cleanup suggestions to repository authors?
Yeah, this is a very good point. One of my PhD students was working on creating a catalog of common pitfalls that we saw when people were using codemeta files, and I mean, you described some of them literally, which is the version number, right? That is very common. So doing some sort of metadata propagation action that you would run in your service is like, hey, well, I saw you updated this, but maybe you also wanted to update it in the setup.py because I see you have a version that is inconsistent now, right? I think these are the common, like the steps that we should move towards. Yes. We are working on right now on the diagnosis. Let's see if we can find all the pitfalls that we found manually. And the next step will be to try and do it some of this automatically through an action or through some software that you can run in your repo. Yeah, that's I think that it makes a lot of sense to me.
Okay, thanks. Just one quick last question. Is this system also compatible with GitLab hosted software?
Yeah.
So if I have, let's say, a Forge, which is private, which is hosted in my own institution, I can use it. Okay, thank you.
Yeah, we tested it out with the OSSR. That they have like a full deployment in GitLab, and they were opening issues we were fixing, but it should be working because the GitLab API is common even if your deployment is private, right? So we have been introducing this, and I mean, the tests that we have done, they have worked. If you face any issues, just let us know and we'll work on that.
Okay, thanks a lot.
No problem.
Great. Thanks again, Daniel, for putting this together while on the road. I appreciate the flexibility. I contacted Daniel just earlier this morning, and his time. So definitely appreciate it. I'm gonna pause. I'm gonna stop the recording here, and then we can move on to other discussions.